So, hello everybody, and welcome to the fifth session of the Open Research Seminar. I am Marco Storni. I'm a postdoc within the project RENEW18, Responses to Newton's Mathematical Experimental Paradigm in 18th Century Philosophy. The Open Research Seminar, as you may already know by now, is a platform where we discuss ongoing research in the international history of and philosophy of science community. And today, our guest is Kirsten Walsh. Kirsten is a philosophy lecturer in the Department of Sociology, Philosophy, and Anthropology at the University of Exeter in the UK. She completed her PhD in 2015 at the University of Otago in New Zealand, and her research is in the history and philosophy of science generally, but she with a focus on the scientific methodology of Isaac Newton. And today we're going to discuss a chapter that she kindly shared with us, which is entitled Proof by Experiments in Newton's Optics. So as usual, the speaker will have 15-20 minutes to present the research, and then Casper de Witt, who is a PhD student in our project, will offer a commentary on the paper. So please, thank you very much again, Kirsten, for accepting our invitation, and the floor is yours.
Thank you. It's a pleasure to be here. Thanks for inviting me, and thanks for reading my paper. It's always a risk publishing things in collected volumes. You worry that they don't get read very much, but I was pretty happy with this paper, and so, I feel like I feel like this always happens to me. I end up putting quite a lot of work into papers that are unlikely to get read by very many people. So, it's nice that you've all had a look at this paper. Okay, so yeah, I'll give you just kind of a quick rundown on the paper, I guess. And hopefully my voice holds out. I've woken up with a bit of a cold this morning, so I'm sort of sipping on some tea, and hopefully my voice doesn't just disappear on us. Okay, so yeah, so this paper, as you know, is a chapter in a collected volume. There is a worry that it's kind of buried. It's it's chapter 11 in a book of 12 chapters, with a very inspiring title of Definition and Essence from Aristotle to Kant. It sounds like a real page turner, right, of a book. Hopefully people will read it though. But anyway, so the book came out of, the book was edited by Peter Anstey and David Bronstein, and it's supposed to be, I think it's actually supposed to be published officially tomorrow. So, it's hot off the press. The book kind of came about through this conference that Peter Anstey and David Bronstein organized at the University of Sydney like a million years ago, back in June 2019. Where it was a pretty interesting conference, extremely dense, and there's a picture of us, because I ended up kind of going, wait, I'm pretty sure I took some photos of this conference, and I took a total of 2, in fact 1, because one of them was a photo of me. But anyway, so it was a nice conference. We all had dinner, we all talked about definition and essence. I remember being horribly jet lagged at this conference, and also having no idea really what I wanted to say about Newton and definitions. I'd written a paper before this on principles in the concept of principles in Newton's work, and I think because I'd written about principles, I think Peter thought that I would have plenty to say about definitions in particular, because at that point he was thinking about definitions as principles, and it was a whole thing, and I really didn't know what I would have to say, so I pulled together some stuff, and went along to this conference, because it was a free trip to Sydney and all of that. Then luckily there was kind of a huge gap between, because COVID happened and stuff, between the conference and us actually having to submit chapters for this book, because then in the meantime, my thinking kind of really developed and went off in a kind of new direction. So what I'm going to do in this brief talk is to tell you about what motivated this paper. I've given you kind of some of the background. I'll just tell you a little bit more about that. And then I'll sort of try and give you my take on what I think the key upshots of this paper are. And then because I wrote this paper really several years ago now, these things take quite a long time to come out. I'm going to tell you about what the next steps have been in this project, because actually it sort of ended up sparking this kind of new area of research for me. So it's been quite fun. Okay, so starting with the motivation. Well, as I said, there was a conference, and when you attend one of these kinds of expensive conferences as a guest speaker, you do feel kind of morally obligated to submit a chapter for the volume that comes out of it. And so at the conference, I ended up, at that point, I'd been thinking quite a bit about a couple of the definitions that are kind of buried in Newton's optics. So in particular, the one that I'd been thinking about most was a definition that appears in book 2 of the Principia, book 2 of the Optics, when Newton has been talking about the colored rings that appear in thin plates. When you push together two pieces of glass and you shine light on it, you get kind of rings of light of different colors. So this is kind of largely what book 2 of the Optics is about. And after Newton had kind of completed a bunch of experiments, he ends up and he discusses them a bit. He ends up introducing this definition, and it's this one that you can see kind of in the center of the screen, where he says the returns of the disposition of any ray to be reflected, I will call its fits of easy reflection, and those of its disposition to be transmitted, its fits of easy transmission, and the space it passes between every return and the next return, the interval of its fits. Okay, so that's probably gibberish to most of you if you haven't looked at Newton's optics that closely. I think for Newton this is supposed to be perfectly clear. But I've been thinking about this definition because it kind of just suddenly gets introduced, and in my view it seemed to be kind of performing this interesting function of kind of stalling a certain kind of conversation that you might have, and kind of changing the direction of the discussion. And so then that got me thinking about this other definition that appears in book 1 of the Optics, that similarly seems to be kind of playing a kind of an interesting kind of polemic role in the discussion. And so I was kind of thinking about those, and the original title of the talk was supposed to be How Definitions Change the Subject, the role of definitions in Newton's optics. And then I was like, but maybe it's really only kind of one role definitions can play in Newton's optics, or maybe the roles of definition, and I can never quite figure out. So I gave this talk that, tried to kind of explore some of these ideas, but I was never that excited by the idea. And the idea was that definitions change the subject, and they sort of shift the framework and set a new explanatory agenda. And this kind of seems to happen for Newton sometimes midway through a discussion. So then anyway, COVID happened, and during COVID, when I kind of realized that I actually needed to write this promised paper, I kind of realized that actually I hadn't really thought enough about the definitions and how they work, how the proper definitions, or the kind of the main definitions work in the Optics. And so then I sat down and worked my way through book 1 of the Optics to try and understand exactly how proof by experiments works and what role definitions and axioms are supposed to play. So since Newton's Optics opens with a set of definitions and axioms, you could be forgiven for thinking that you would find a demonstrative method of proof in the Optics, because this is what you find in the Principia, and this is what you find in most books that are set up this way in the period. But instead, you find him using, like I've said, a proof by experiments. And what I hadn't fully realized before I really delved into this was that definitions and axioms just don't play an explicit role in the proof by experiments. They just don't really get referred to or mentioned. And so that led me to instead decide to kind of focus on these two kind of main questions. How does proof by experiments function as a proof? Like, where does the probative force lie? And then the second question, because of course this was a volume on definitions and essences, so I needed to have something to say about definitions. what roles do axioms and definitions play in the trajectory from experiment to proven theorem? And so that's where I kind of, started from when I sat down to write this paper. Okay, so now just what are the key upshots of this paper? Okay, so like I've said, in the Opticks book 1, Newton employed this proof by experiments, and it's supposed to kind of support his theoretical proposition. So the structure is, as you can kind of see it on the screen in front of you, Newton starts with, a proposition, theorem 1, lights which differ in color differ also in degrees of refrangibility, and then he gives us his proof by experiments, where he just describes 2 experiments in a row, and that's supposed to kind of give you the knowledge or the proof of that proposition. Same thing happens with proposition 2, and so on. So we just get these, I should read out proposition 2, because that's the one that I focus on in the paper. He says that the light of the sun consists of rays differently refrangible. And again, he just kind of states that and then gives us a series of experiments, and that's supposed to somehow give you knowledge of that proposition. Okay, so and what I ended up kind of concluding when I looked through these things was that the results of Newton's sequence of optical experiments are not supposed to be accepted on the basis of testimony, but on the basis of experience. They're supposed to be enacted by the readers. And so my thought was that some way, in some sense, this process of inaction, or enactment, is supposed to give you the proof of the proposition. So I'll just quickly run through part of the experimental sequence that I do describe in detail in the paper. Okay, so Newton gives us so Newton starts with experiment 3 when he's talking about proposition 2, because he's given us 2 experiments to support proposition 1. Okay, so the first experiment 3, is this one that's kind of deceptively simple. You have light goes in through a hole in a window shutter. It gets projected through a prism and onto a far screen. Newton describes the conclusion, well, the result of this experiment. He says, ordinarily we would, if under the kind of previously accepted theory of light, we should expect to see a circle on the far screen, but instead what we see is an elongated circle or an oblong. Then he carries out, then he describes experiment 4, same experimental setup, but instead of kind of looking at the far screen, the experimenter kind of looks through the prism back at the aperture in the window shutter. And you look at kind of what happens there. And again, where you should expect to see kind of a circle or an aperture shaped thing, hole, instead you see an elongated hole. And then Newton describes experiment 5. At this point, he gets out another prism and inserts it kind of crossways to the original prism, and he kind of carries out an experiment that way and looks at what happens. Again, he kind of describes it by saying, like, what you expect should happen. So in the first experiment, with just one prism, you get an elongated spectrum. And so again, if the received laws of refraction were correct, he says we should expect to see a kind of that the image kind of stretch out in the other direction as well. But instead, what we see is that it lands in a kind of diagonal instead. Later on, in the discussion, he conceptualizes this a bit more carefully. He says, well, if the white light kind of was projected onto the far screen without any kind of prism in the way, we should expect to see a single circle, the shape of the sun. But when the light goes through that first prism, it gets broken down. It gets separated into its component parts. And so we can kind of conceptualize that as a sequence of interlocking circles. And this shows us that, and then when we put the other prism in a crossways position, those separated circles should stretch out that way. So he kind of ends up explaining it that way. And he ends up putting a little lens in between to kind of get that sharp image, and he actually is able to produce something that looks a bit like those interlocking circles. Okay, and then he gives us experiment 6, which is kind of a pretty famous experiment for Newton. In his first optical paper, he calls it his Experimentum Crucius, but here it's just experiment 6, one of 12 experiments, I think. Okay, and in this experiment, he's kept the extra prism, but he's added a couple of extra screens that he lets just small amounts of light through. So kind of what he does here is he projects light onto the first screen, then he uses the apertures in a sequence of screens to kind of thin out the light, just select for just a tiny bit of that original beam of light, and he projects that tiny little beam of light onto a far screen. And he kind of notices that when you send through, you can send through different parts of the spectrum through the aperture, and it can land on different parts of the wall. So what he ends up saying is that when you send through a low part of the spectrum over here, it lands on a low part of the wall over here. And when you send through a high part of the spectrum over here, it lands on a high part of the wall over here. Okay, I won't keep on going with the experiments because, as you will have seen from the paper, there's a lot of them. They get increasingly complicated, but those are just kind of a couple of the ones that I was thinking about. So, okay, so like I've said, the results. My take on this was the results of Newton's sequence of optical experiments were not supposed to be accepted on the basis of testimony. In fact, Newton never really just states the results of individual experiments propositionally. He kind of describes them kind of phenomenologically. He just sort of describes how they look and kind of keeps moving on. And so my take on it is this, that you're supposed to kind of experience the experiments. Okay, so some of the conclusions I ended up drawing from this. Well, okay, so one of the things is I kind of ended up picking up where a couple of other scholars have left off, really. So it's been recognized by several scholars that there's no explicit inference from experimental results to proposition in Newton's proof by experiments. So as Philippe Hamoux puts it, the demonstration is, so to speak, embedded in the experiments themselves, or rather in a tightly woven net of successive experiments. So Hamoux sort of tries to articulate what's going on here too. Darnajalabanu makes a similar kind of point concerning Newton's earlier work when she talks about Newton's Experimentum Crucius. She argues that the proposition that light is composed of rays of different refrangibilities is a constructed experimental fact that's obtained directly from the Experimentum Crucius. And so I think that that the knowledge of the proposition is really given by or emerges from that sequence of experiments. You kind of have to experience the entire sequence or something like that in order to kind of get the experimental results. So, and this means that the probative force of Newton's proof by experiments lies in experience. And so that means that for someone to come to know proposition 2, for example, it's not enough that they have propositional knowledge of the experimental phenomena. That is, it's not enough for them just to kind of know the experimental results. Rather, they need to experience the experimental sequence. And so the proof doesn't just turn on the experiments kind of delivering the right results, but on the would-be knower engaging with the experiments in the right kind of way. And so that my thought here is that kind of enacting the optical experiments is supposed to kind of facilitate a deeper grasp of the phenomena than merely knowing the experimental results. And this kind of experiential grasp of the phenomena, I think we might call this maker's knowledge. And I think this is how I cast it in the paper. It affords kind of knowledge of the proposition. Okay, so from that so the point that I was trying to get to was that experimental results are not accepted on the basis of testimony, but on the basis of experience. So enactment. I ended up choosing the word enactment to talk about this after I saw, I think, Darnajalabanu talking about this in Bucharest one time, where she was talking about the idea that that it's not just about kind of trying to replicate the experimental results, but about exploring and improvising on a sequence of experiments. And so I thought that kind of captured more what was going on here. And the goal of enactment isn't just replication, but like I said, to come to know the proposition through the experiments. And as for how the definitions and axioms what role do definitions and axioms play in all of this? Well, Newton's using things like definitions and axioms as well as textual descriptions, diagrams, and so on to provide what I term a prescriptive framework. And so the idea is that you have to kind of experience the experiments in the right way. And this prescriptive framework, these definitions and axioms and so on, guide the reader or enactor towards the right kind of experience. Some other kinds of conclusions I ended up drawing, or upshots of this, I ended up linking this back to the kind of the challenge that early modern experimental philosophers, I think, were facing at the time, that they needed a new method of proof, that the demonstration method of proof just kind of wasn't able to do what they needed it to do. And so they needed a new one that would allow them to treat well-established experimental phenomena as, in some sense, foundational. And I think that Newton's response to this challenge was to appeal to proofs bound by experience of the rightly prepared, rightly embodied actor. In short, Newton's proof by experiments represents, I think, a creative solution to an urgent problem that was being faced. I don't want to overstate the originality of Newton's solution. There is a precedent, there's the Baconian precedent here, and also Boyle kind of used talked about a proof by experiments as well. But I think, so I don't want to kind of overstate Newton's importance here or Newton's novelty, but I think there is an interesting kind of proof going on here. Okay, so the final thing I just wanted to briefly flag is that there are this has led me to think about new ideas. This was kind of the starting point for me on a kind of interesting philosophical project, I think. So the idea, so I've explored the kind of notion of enactment in several ways. So it's kind of tempting to think that well-constructed experiments require very little interpretation. Philosophers of science often don't really talk about the work that goes into kind of interpreting or understanding experimental results. There's sort of a sense in which they're supposed to just speak for themselves. And you might think that, in fact, well-constructed experiments the results should speak for themselves, because otherwise, why would experimentalists like Newton place so much emphasis on enactment and replication of the experiments if that's not supposed to be, a key thing? But I just don't think it is the case that carrying out the experiment or sequence of experiments correctly, or whatever that means, will kind of compel you to assent to the conclusions. Rather, I think it turns out that you need to enact the experiments in a way that will kind of afford phenomenal grasp. There has to be extra work going on there in some sense. So I've explored this notion in several different ways, in kind of recent and kind of under review publications and things like that. And so, for example, I've got a forthcoming co-written paper with Alice Murphy and Adrian Curry on aesthetics and agency in experiments, where we talk about where we kind of use this example of Newton to explore this idea that good experimental design facilitates aesthetic agency. I've also got an R&R on a paper with two of my colleagues. Well, again, Adrian Curry and also Tom Roberts. Sorry, these are like the front. These are the title pages for talks that I've given with them, and so they tend to be a bit sillier than the usual ones we do, because they're usually for our colleagues in places like Exeter and so on, where we can be a bit more casual. But anyway, and so Tom Roberts and Adrian Curry and I have used the tools of situated cognition, so 4E cognition, and also Floridi's notion of maker's knowledge to give an account of how it is that experiments might compel assent for somebody like Newton. And And so I think one of the lessons gleaned from these kinds of explorations is that you have to experience the experiments in the right way through a prescribed conceptual framework. And so I'm kind of currently working on a paper on my own that's on thinking about whether some frameworks kind of are better than others, and that's led me into thinking about whether the very kind of deep disagreement that Robert Hooke and Isaac Newton seem to have in the kind of 1670s about the results of the experimentum crucius, whether that comes down to a difference in their prescriptive frameworks, and whether one prescriptive framework might end up being more fruitful than another one, and things like that. And I think that, and we're also interested, again, with Adrian Curry and Tom Roberts, and another of our colleagues, Adam Toon, we're sort of talking about developing a bigger project on using forecognition to understand early modern science, and sort of pushing forecognition to say some interesting things about epistemology, and so on. So yeah, so it turns out that I think this has been kind of quite a fruitful starting point for me. And I will leave it there. Thanks. Stop share.
Okay, thank you very much, Kirsten. I really enjoyed the paper, and I'm very interested in what the rest thinks of it. So I will just now start off the discussion with my comments, and then after that, the floor is open to all. So, well, my comment to the paper is basically historical in nature. I wanted to address the historical and polemical context of the optics and the use of experiments as proof. Now, you clearly indicate that the ideas of proof or demonstration and how they should be achieved were undergoing much change in the course of the 17th century. Now, certainly in physics, the optimistic mood of the 17th century natural philosophers about the ability to gain knowledge about nature was also accompanied by difficulties in how this knowledge could be gained and demonstrated. I think that, at least for many Cartesians, on which I mostly focus, in the second half of the 17th century, there was quite some ambivalence around the topics of proof and demonstration, and ambivalence around what these natural philosophers hoped to do and what they actually were able to do or were actually doing. So on the one hand, people were optimistic since they finally got rid of all the superfluous categories and beings from Aristotelian natural philosophy, and they were able to simplify nature into matter, leaving aside the mental part of the Cartesian duality, and redefining matter purely as extension in motion, nothing else. And extension can be measured, motion can be measured. Just like you stated in your introduction, geometry, of course, was of course still appreciated as the ideal of valid reasoning. On top of this, Descartes provided everyone with his laws of motion, and with a powerful image of the tree of knowledge, where the metaphysical roots give us certain principles that he has achieved through his hyperbolic doubt. And these things taken together on paper seem to provide the perfect recipe for a mathematical science with an attainable goal of certainty through measurements, geometrical reasoning, all being based on firm grounding principles. A very promising recipe. But one of the things that struck me most in actually reading these late Cartesians is that this was generally not what they did at all. So many 17th century natural physicists, they did not use quantifiable methods to try and achieve certain knowledge. Instead, they made qualitative statements about nature, and sometimes even very explicitly acknowledge their lack of certainty and that they were doing speculative physics. And this gave rise to debates about unobservable microscopic structures, the existence of a celestial ether, and other things which escaped observation, escaped measurement, let alone was able to decisively prove anything. Now, Newton had been confronted with these discussions a lot, maybe most famously about action at a distance and the existence of the vacuum. And Newton did not seem to like these discussions very much. So the point that I want to make is the following, that Newton's optics was indeed, like stated in your chapter, a creative solution to what proof by experiments was supposed to be. But not only that, I see it also as a very successful argument for the debates with contemporary philosophers about what kind of proofs natural philosophy in general could possibly rely on. Geometrical demonstrations were good and all, but it clearly was not so easy to make those kinds of demonstrations in physics. And the speculative side that physics found itself in during the late 17th century was also unsatisfactory for Newton. So with the optics, maybe Newton also hoped to be able to do much easier than in the Principia, to sidestep criticisms about certainty, about underlying mechanisms, and to not get bogged down in metaphysical discussions. He could literally take the reader by the hand, well, not figuratively take the reader by the hand, and to questions about proving or demonstrating whether he said was correct or not, he could answer, I will show you. It's the probative force of the experimental sequence. Now, as optics lends itself much more easily to experimentation and manipulation of the objects of investigation compared to astronomy, try manipulating a star light years away. In the optics, Newton could actually walk the reader through the steps. And going through the steps was exactly what held the probative force, like you so nicely put in your chapter. So kind of to end this comment is, I would actually just want to ask you if you kind of agree with my point that the optics was at least partly written as a response to the speculative philosophers and their polemics who had criticized Newton's earlier work. And another more basic question, since I have so far in my investigation have focused mostly on the resistance against Newton's physics and not the optics, I would also be interested in learning if you perhaps know what kind of criticisms this experiential sequence in the optics, what kind of criticisms it attracted. So that's my comment and my two questions, basically. Thank you.
Thanks. Should I respond? Yeah, I'll respond now.
Yeah.
Yeah, those were great. Some good questions there. I think I agree with you about the kind of the first point. The idea that Newton does, even from his kind of earliest optical work, Newton kept on kind of encountering these complaints, these criticisms that his work. I mean, this happened both with his account of the composition of white light and also with his, conception of universal gravitation, that these things didn't fit with the kind of underlying metaphysics that people had accepted. Neither of these. Well, so in the case of gravity, it's that it doesn't seem to. You can't really use a kind of mechanical metaphysics to kind of capture what's going on with gravity. And with the composition of white light, it just doesn't fit with the kind of the standard view on the table at the time, which was that light is a is a wave or a vibration or a pressure through a medium. And in both cases, Newton ends up kind of calling for a revision to the kind of underlying metaphysics. But at the same time, he also, like you say, doesn't want to get bogged down in those kinds of discussions. He thinks that those kinds of things are something that we can just be kind of doing later on the side. You know, what we need to be, you know, figuring out first is the physics. And so, yeah, and so I think that you could be right that that part of what's going on, at least in book one, and I think this is also because this is a striking difference between the way that Newton presents the findings in book one of the Opticks versus, you know, his first optical paper in 1672, where in 1672 he kind of goes in all guns blazing, declares a kind of revolution in optics, you know, introduces kind of a single experiment that he calls an experimentum crucius, that he declares it's kind of given him certainty about the composition of white light. And he also kind of hints that maybe it's kind of this really strong kind of mathematical kind of certainty. And therefore he's kind of produced a science of color. And then he goes on to kind of, you know, to kind of imply that this means that light is made up of particles or corpuscles, you know, so he kind of gives us and then so he says, and therefore we can kind of solve this metaphysical question about when there's colors in the dark. And, you know, he does it all in that first paper. And of course he gets heaps of criticism for that. And, you know, so much criticism that he nearly ends up kind of giving up philosophy altogether. And so then, yeah, and so then by the time 30 years later, he's written the Opticks, he, you know, the propositions are still pretty much the same in book one. But the way that he defends them is so different. So instead of just giving, you know, a single experiment, he gives us a whole experimental sequence. He kind of stops using the language of certainty, and so on, but he still insists that this is a proof. So that kind of still suggests that this is not just kind of, you know, these propositions aren't just highly probable. It's clear that he thinks that they're kind of, you know, almost beyond doubt, probably, and so on. Yeah, and so I think that, yeah, and so I think you're right that there is this thing going on here where he is kind of, you know, giving us some sort of response that kind of can allow him to sidestep a lot of these, you know, a lot of these complaints and discussions. It is interesting though that's what book one looks like in the Opticks, but in book two, Newton does then rely much more heavily on the kind of underlying metaphysics that you know, the metaphysical picture that he's got of light is kind of one where light is corpuscular and it's moving through a kind of some sort of optical ether, and the phenomena of color and things like that are a kind of phenomenon that emerges from the interaction between the light and the ether. And so he has this whole picture, and that picture ends up doing a lot of work for him in book two. And so it's not clear. It's not clear why he thought that was something that he could get away with there, except maybe, I mean, but he sort of did get away with it. Maybe because nobody read book two, or maybe no one really interacted with it very much. I'm not sure. And then of course, in book three, he gives us all the queries where he really does go into the metaphysics in a big way. But that, again, that doesn't seem to have opened him up to too many criticisms. There are a few, but people seem to be more approving of the fact that he was really letting himself speculate at that point. So yeah, so those are some of my thoughts on that. Like, I think in short, that I think you're right that Newton is kind of using this as a way of, you know, he recognizes that there's this new, that a kind of a new way of delivering a proof kind of is required, and that this gives him a way of kind of sidestepping a lot of the criticisms. But it does raise these new questions about why he kind of permitted himself then to kind of go buck wild with the speculating and other parts of the book. As for the kinds of criticisms it attracted, I know that Newton's work encountered a lot of criticism from people like Goethe and so on. And so my sense is that there were some complaints about the way that Newton defines color. But actually, I haven't really delved into that in enough detail to fully understand what kinds of criticisms he might have got. Certainly in Britain, you know, people seemed very pleased with the work. And in fact, it sort of seems like people have mostly focused in on the last couple of queries in the optics. So I'm not sure that many people have really gone in, like, worried too much about the details of the experiment, of the proof by experiments. But I'm not sure other people might know more about this. You guys do much more work on the kind of 18th century Newtonianism, don't you? So you might know.
Okay, thank you very much. I will now let anyone else who has a question. Yeah, sure, Ovidio.
Yeah, I guess you can all hear me, right?
Yeah.
Right. So thanks so much, Kirsten. Yeah, I really enjoyed reading your paper, first of all. I think it's very clear, and I think it follows very naturally from kind of the starting point to kind of the point which you want to kind of be the offshoot of the paper. Right. So I mean, I have several questions, I think. I'm gonna start kind of my first kind of question is a question about the framing, right, of the paper. So you start by making this kind of sharp contrast, right, between demonstration and proof, right? So the point is, you know, there's this idea of proof, like to show the truth of something, and there is this demonstration, which is a species of that, which is like the gold standard of proof. And then you say like this gold standard was best exemplified by Euclidean style, right? So kind of deducing and giving demonstrations to certain, based on certain principles and so on. First thing I wanted to ask is how do you, so I confess I mostly like use these two words interchangeably, right? So I make absolutely no difference between the two. But say there is a difference between the two. I always thought that, you know, the strongest of the two, so let's call it the demonstration, was not really Euclidean demonstration, but was more like Aristotelian demonstration, right? So syllogisms, which is kind of different in a way from Euclid, right? There was also this whole debate in the 16th century and 17th century about certainty in math versus certainty in syllogisms, right? And the point being that, yeah, you know, so syllogisms are demonstrative, are more demonstrative than math, than Euclid, because they also have this causal element, right? So they kind of explicate a cause, like the formal cause, right? Whereas for math, it's complicated whether like the inferences, right, actually do refer to any kind of cause. And of course, if we take Aristotle as the standard, a syllogism, so a demonstration has to account for some sort of cause, right? So I wonder how do you take this to be like the distinction to be drawn between proof and demonstration, like this kind of mathematical ideal of Euclid? So that's my first point.
Okay. Okay. So my understanding of this is that is all Aristotelian. So the thing that was kind of that we talk about as being the Euclidean proof was actually a kind of Aristotelianized version of what Euclid was talking about. So so I think the thing that the early moderns kind of saw as a Euclidean, as the gold standard of kind of this geometrical proof was a kind of Aristotelian version of this. So I'm not sure that there's much difference between the kinds of the syllogisms you're talking about and the geometrical proof. I think the main difference is that maybe the principles that they're starting from are different. In the case of the geometrical proofs, these are mathematical or geometrical axioms or principles rather than the other kinds of self-evident, necessary truths that they're playing around with, or something like this. So I'm not sure. My understanding of this is that I could be wrong about this. I might need to read some of the other chapters in the book, in the Anstey Bronstein volume to properly understand this. But my understanding is that it's basically that the natural philosophers kind of saw this mathematical model of proof, or this the Euclidean gold standard, and we're trying to figure out ways of using that reasoning in natural philosophy. And so that was so I'm not sure if I can give you a good answer on why they chose that particular version of proof, and I'm not sure how different it turns out to be really from other like the standard Aristotelian syllogism. I'm kind of relying on what Peter has told me about this. But yeah, so I might have been a bit fast and loose with maybe how I've characterized that distinction. Yeah, do you have thoughts about this?
No, I mean, so one thing which would be kind of helpful would be some sort of reference to kind of the the type of literature which really makes this distinction, right? No, my only thought, so also this is really just kind of background knowledge for me, but I always thought, the point was, yeah, you have demonstrations in syllogisms, and let's say you have demonstrations in, let's say, in the elements of Euclid, right? So if something is a theorem, then you can prove it. But I always thought that, yeah, you can, so both are kind of save certainty, right? So both kind of conserve certainty. But the difference is kind of that math extends knowledge to some degree, right? Whereas, syllogisms, basically what you put in is what you get out. There's nothing new, right? That was the whole criticism of 17th century people like Descartes, right? So this is kind of on the side of the math. But then the problem with the math is that, you have this whole divide, this whole thing, which Newton is explicit about, on the one hand, like geometrical optics, and on the other hand, the more physical stuff, right? So if you go on to really emulate the standard of proof in math, particularly one strong criticism you might face would be, yeah, but what you're actually doing is just math. It's not about nature. It's just about, your lines and your whatever it is you kind of defined, the way you kind of defined your elements with which you operate, right? So yeah, so I think, I mean, I don't really have any thoughts on this, but some kind of it would be helpful for me just to kind of know this side of the perspective as well, to kind of know some sort of example of people who were really conflating the two and really were turning over to Euclid as the kind of, best proof you could ever have in matters of certainty, in matters of whatever it is.
Looks like Marco has got a
I mean, I've seen other hands, but I'll follow up on that. I think that one element that might be interesting is that, at least in the Latin version of Euclid, there is no reference to probatio as a juridical term. Use demonstratio, demonstration. So in the original, we should
that
see the Greek original, but that's interesting. Another thing, but it's more on the side of like 18th century speculative philosophy, as it were, Wolff and this kind of people. And my feeling is that Euclid is a model of rigor, but you don't actually look at the structure of his demonstrations, meaning the proof of the propositions. Whereas syllogism, like, of the first figure in particular, is regarded as a form of natural reasoning. So in Aristotle, you find the actual model you use to demonstrate. In Euclid, you find the general model of rigor and this most successful application of the best logic you can have. That might be, I mean, that will be my take on the matter.
It's helpful, thanks.
Yeah, unless Henny is the first, unless there's a direct follow-up to this question, Arnaud?
So actually, I don't know whether it's a follow-up or not, but mine was really related to this. So may I
Go ahead.
may I go? Okay, thank you. So good afternoon, Kirsten. I think that's the first time we see each other since this conference in Oxford, where you gave this paper on embedded cognition. I think you were referring at the end of your talk.
Yeah.
So yeah, my question is exactly on this, and actually there was on the difference between Euclidean and Aristotelian model, because it seems to me that since you rely on what Philippe Amour says about how experience or experiments are embedded and are part of the proof, it seems to me really close to what Euclid does or did in contrast to an Aristotelian syllogism. So there are several studies recently underlying the fact that diagrams play a very constitutive role of a demonstration in Euclid, so they are not apart from the demonstration, but really part of it, so that you cannot separate the diagram from the text, so to speak. And on reading your chapter, I had the impression that, well, proof of experiments play kind of a similar role for Newton, so that you cannot separate the experiments. And I think that's the conclusion that you reach. You cannot separate the experiments from the whole inference, so they are not you cannot draw everything from the experiments, but well, they are really embedded in the proof. So so that was my question actually, but whether you don't see that there a really similar structure, a real similar, I would say, purely Euclidean structure. And if I say so, I think at the end, perhaps I'm wrong. I misunderstood you. You said, well, there is something like a kind of new method for Newton, new method of proving. Well, perhaps it's just I'm kind of Euclidean, new modeled way of putting things. That was just a suggestion because I don't have, but that was on this exactly. Yeah.
Okay, so I take it that the place where you kind of ended up was thinking, well, there is a kind of history of doing certain kinds of constructive proofs, and that maybe Newton's proof by experiment could be understood as a kind of proof by construction or something like that.
Right.
Is that yeah.
Right.
I think there's something to that, but I think, and I think what I'm trying to kind of capture, I think there's kind of this idea of this kind of proof that this kind of proof by experience or something like that probably could look like that in different cases. I think that, I think that when you're kind of, learning mathematics and you end up, and you do a lot of exercise, you do a lot of mathematical exercises and you kind of work your way through a bunch of different, proofs and things like that. And that's the thing that kind of facilitates that grasp, that kind of understanding or something like that. I think, and in that case, it's a very much it's a constructive process that you're kind of putting together the things. It could be that something like that is going on in some of these experimental cases as well. What I was kind of trying to get at, in addition to that, was what I've been sort of trying to understand now is what that what that feels like, what that experience is. Why is it that, because like Newtonian certainty, the way that he talks about, you can, the way that certainty is this kind of compelled assent, and the way that, you can, and carrying out an experiment in the right way, or having the experience of doing an experiment, can kind of compel you to assent to the proposition. That's a very kind of phenomenological way of thinking about assent. It's about, about certainty. This is a kind of, psychological kind of certainty. It's about grasp. And so I think what I've been trying to understand is how that process works, which is why I think, like the closest I've seen to people kind of recognizing the embeddedness of these experiments in the proofs is in the work of people like Philippe and Dana, who have kind of articulated this idea that there is this, that they are kind of just, that the experiment is just kind of embedded, but they haven't kind of pushed that further and kind of tried to think about, in that case, how that works. And so that's what I'm sort of trying to do. That was a really convoluted answer to your question, but yeah, I think I do think that there's something to be said about kind of constructive proofs versus I forget what they're called. Sorry, my brain is not working very well today with this cold. But there's, you know, there's the proofs where you kind of construct the proposition from your principles, and then there's the proof where you take apart your proposition and bring it down to the principles. And I'm not sure that if those are the two options on the table, I'm not sure that Newton's proof by experiments is entirely just a constructive proof. I don't think that there are principles there really. I think that the principles that are the definitions and axioms are playing a different kind of role. Yeah.
Yeah, I don't know. I see that Ovidio has a follow-up. No, so what basically my question was not to say surely the object is really new, but and I ignore this, but wherever we can just coin this as a new method, that was my point actually. You know, you can always say that you borrow always something, but you add something new. But in this case, it seems to me that it's so similar that perhaps it could not be. But that was just a, you know, a reflection loud now, but no further deep reason. But then I see that Ovidio has an answer to this.
Yeah.
No, the only thing I wanted to say would be, yeah, one way to cash out what Kirsten was saying would be to the old school categories of analysis and synthesis, right? So yeah, there's this proof which usually has both parts, right? There's an analytical one of like splitting the problem into pieces and so on, or like assuming that what you're trying to prove or find is out there and then drawing consequences. And then the constructive one, you just put everything together from principles or definitions. But I'm actually not, I don't think this is a useful way of understanding specifically, especially these the optics, these parts, because I mean I definitely agree that there's something else happening there. So, but that's the only thing I want to say on this.
Yeah. I mean, I think it is like the question about how novel this approach is, I think, is a good one. In that, you know, I'm not sure exactly how, you know, novel this is. I haven't been able to find many places, well, in any places where you see such a fully fledged proof by experiments labeled as such. This does seem to be kind of, you know, novel in that respect. You know, we know that people like Boyle and Bacon kind of had this, had the idea of this kind of thing, but it's not clear that anyone really tried it in the kind of, you know, in the way that in the way that Newton did. But I think that, you know, in the background of this, I think it's clear that proof was a much more varied, much more lenient concept than it is now. If you talk to mathematicians nowadays, even you know, philosophers who are logicians, you know, they have really strict views on what constitutes a proof. And I think it just turns out that in the early modern period and before that, you know, there were many different kinds of approaches to this on the table. I think that by the time Newton was working, like, you know, the demonstration model was kind of being still held up as the gold standard, but it wasn't the only way of doing it. So yes, so this question about novelty, you know, is something that actually Peter Anstey and I have both been kind of separately trying to dig into a little bit to kind of see if we can get a sense of what, you know, of what else kind of this looked like, I guess is the way of putting it. Yeah. But yeah.
Thank you.
I think it's finally Henny's turn. Go ahead.
Thanks a lot, Kirsten, for a very clear paper indeed. So I enjoyed reading it. I have a question that is a little bit related to what has been said. It's on the distinction you make between virtual witnessing and material enactment. And so at one point in your paper, it's on page 259, you say that both may be satisfactory ways of experiencing Newton's proof by experiments. And then you spell out some benefits of material enactment over virtual witnessing. And while some of these benefits, for example, is that the experimenter becomes an active component of the experimental setup, then material enactment requires one to know how to look and not just where to look. Material enactment requires one to develop embodied skills to interact with the experimental apparatus and also through the apparatus with the world and so on. And then you end this paragraph with a sentence in which you say that virtual witnessing does not facilitate agency in the same way, but how important these material aspects of enactment are to the probative force of the experience isn't clear. You say then, you write, it may turn out that the process of mentally constructing the experimental sequence facilitates a different but similarly strong phenomenal grasp. And in your presentation today, you at a certain point near the end, you said that it is not the case that carrying out the experiment correctly will compel assent, rather one needs a phenomenal grasp. And so I wanted to push you a bit on this distinction between virtual witnessing and material enactment. And so it's a bit close to what has been said, I think, with respect to Euclid. If we look how Euclid writes down the postulates, for example, he writes down, well, at least the first three postulates as actions to that the reader has to do. For example, to draw a straight line from any point to any point, to produce a finite straight line continuously in a straight line. And so when you were writing about virtual witnessing, I think this is kind of what is going on in Euclid, because you do an action, but you can imagine doing it without actually drawing it somewhere. And so I'm well, a little bit silly question is perhaps, I guess you haven't enacted these experiments yourself. So how serious do you take the benefits of material enactment that you spell out on this page? Because if you really were believing it would bring you so much more, I mean, you also would go and experiment, yeah? So, but I guess you didn't. So you have the impression you understood everything there is to understand about these experiments by spelling them out in the way you did. So by virtual witnessing them. And so perhaps this is also in Euclid, this is sufficient as a convincing proof. And is this not a little bit relativizing the, let's say, the material necessity of the enactment?
Yeah, I mean, good question. I have actually, I've never, actually reconstructed the experimental sequence, but I have played around with prisms to see whether I can in fact produce the thing. So like I have done a little bit of that, which is why I know that the stylized versions that I produced on the screen are nothing like what actually happens. But yeah, no, okay. So this was something that I felt like I needed to address in this paper because it seemed like an obvious concern that people would bring up, you know, because the Chapin and Schaffer line that in fact this kind of writing descriptions about experiments are really just you know, this is kind of polemical, and in fact what the goal is to kind of facilitate virtual witnessing, which has this effect of you know, multiplying the number of you know, observed instances of the phenomena without actually having to carry out the experiment so many times. Yeah, they've got kind of an explanation for it, and I do think that there is something interesting in the idea of virtual witnessing, like, because, you know, like you suggested, you know, this is how we all read these old books, right? Like, you know, when you're trying to understand how, you know, when you need to kind of work through a sequence. I mean, I've done this with lots of different of Newton's experiments in different places in his notebooks and stuff. Yeah, you don't carry it out yourself. You just kind of, you spend a lot of time trying to figure out, actually, you try to virtually witness the experiments. Okay, so the thing was, in this paper, I knew that I needed to address this, but I didn't think that it really mattered too much for my argument what position I took on it, because I don't think my argument stands or falls on whether you can get the same result from virtual witnessing or not. But I did think it was a kind of interesting opportunity to think about whether there are differences in the way that you would in the kind of experience you would have with the experiment if you were virtually witnessing it versus materially enacting it. I think one thing that comes out of material enactment that you don't get, I don't think, from virtual witnessing is, at least not when I've sort of attempted to virtually witness this. So, you know, I've got an example of one, or a sample of one, is the kind of improvisation that you can do with the experimental apparatus when you're doing it materially, you know, where you can, on a whim, you can put in an extra prism, you can kind of put in an extra lens to sharpen the image or whatever. You know, you can do a whole bunch of different things when you've got the apparatus in front of you and you're materially manipulating it, which I think those things, I think that kind of improvisation has benefits beyond just producing more interesting phenomena. I think that there's a kind of epistemic good that comes from this. Yeah, in addition to just kind of producing more results that you don't get from material witnessing. In another paper, I mentioned the paper, and I think I cite it in this paper. I have a forthcoming paper on aesthetics and agency in experiments. And in that paper we talk about how a well-constructed or well-designed experiment is one that facilitates aesthetic agency. So the idea there is that so we use machinery developed by T. Nguyen in his book Games as Agency, where he talks about this kind of this epistemic good that comes from experiencing agency in the right way in a gaming context. And the idea is that games facilitate a certain kind of striving in the player, in the same way that experiments facilitate a certain kind of striving in the experimenter. The idea is that you have that if you've got the right experiment, if you've got the right instruments and you've got the right skills for the task, then the experience of producing the phenomena using your skills and the experimental apparatus and in short, kind of your experience of kind of inserting yourself as part of that experiment will kind of facilitate a certain kind of striving that leads to a positive affect or a positive experience, which we kind of cast as that kind of aesthetic experience, which is also an epistemic experience. Is the kind of, so it's a kind of complicated the way I'm trying to explain it. But anyway, so we sort of use that kind of machinery there. And in that context, we end up saying that virtual witnessing doesn't give you the same kind of striving that materially enacting an experiment does. And so again, we just don't think that you, like we think that you can experience all sorts of things virtually witnessing an experiment. You can definitely you can definitely have certain kinds of aesthetic experience when you're virtually witnessing these kinds of experiments, but we don't think that you get the kind of the highest kind of aesthetic experience that you would if you were carrying it out in person. A tricky counterfactual, but yeah, and so that was kind of so in the background of me kind of ultimately going, well, it seems like enacting is going to be really important here. That was kind of what was going on in the background, where there is another paper in which I kind of say, in fact, I don't think that that virtual witnessing is quite going to get you there. But that's in a kind of very different kind of context, in a very different kind of discussion. And so I felt like for this context, it didn't really matter. I am also in like discussing co-writing a paper with someone else who works on kind of online you know, on online socializing and things like that, and thinking about virtual witnessing and like the parallels between virtual witnessing and say and other kinds of online experiences. And so I suspect that in that kind of paper we might end up trying to find some machinery that will articulate what the epistemic goods are that come out of virtual witnessing, and maybe those are things that are entirely different to the things you get from material enactment. So it might turn out that we have something interesting to say about virtual witnessing at the end of the day, but I'm not quite there yet. I'm not sure. But yeah, not sure if that is a satisfying response.
Yeah, thank you.
Yeah, Marco.
Thank you very much. I have, I think, a follow-up to Annie's question, and specifically about virtual witnessing. So as far as I could understand, the difference that you make between virtual witnessing and just testimonial assent would be, well, testimonial assent would be Newton just saying the results of his experiments, whereas virtual witnessing is following through the experiments. But I was wondering whether virtual witnessing doesn't also involve a certain part of testimony or testimonial assent, because I would say that, I mean, as far as Newton is the one who performed the experiments, and I'm just reading a piece of paper where he talks about the experiment itself and the results, I'm, so to say, trusting Newton, or perhaps Newton's authority in some cases, that these experiments are performed correctly. I'm accepting a certain framework that he proposes to me as a reader, and therefore I might have even the impression I'm witnessing something more actively, whereas I'm just trusting Newton on many things. So I don't know if you agree, and if there is anything you might want to say in reaction to this.
Yeah, I do. I do think that that this is a way of kind of you know, using testimony. I think in this kind of case, you know, certainly like you, when I go through these experiments, there is a sense in which I'm trusting what Newton has to say about the results. You know, and it's actually really striking because there are other contexts, and so one of the things I think about here is that this is how it works for me, because I know that, you know, the kinds of experiments that Newton carried out in book 1 of the Opticks and the way he describes them is more or less kind of correct. That is how those experiments kind of go, and so I can kind of trust that. But of course, that's not how it was at the time. At least maybe by the time Newton published the Opticks, a lot of the stuff that Newton was writing about in book 1, it wasn't really new anymore. You know, so maybe it did work that way there. But in Newton's early optical work, you know, and again, you know, he describes these experiments, and of course people people disagree about what the results of those experiments would be. And so virtual witnessing wouldn't, I don't think it would work in that context unless you could find, so I think that, you know, if everybody agreed that in that first experiment where you've just got the one prism and you send the light in and you get the elongated image, if everybody agreed that that's what happens in that experiment, then you might be able to, then you might be able to convince people by getting them to virtually witness the experimental sequence. But the problem was that people disagreed even about that. You know, you get the Jesuits at Liège claiming that that's just not the result that you get from carrying out that experiment. They end up saying, well, no, if it's a sunny day, then you do get a circle, you don't get an elongated image. And if it's a cloudy day, you do get an elongation, but it's the other way around. It's kind of sideways. It's kind of parallel to the position of the to the prism rather than lengthways, and so they disputed what the result was, and they had real trouble kind of replicating the results. And so it's clear that for those people, virtual witnessing was just not on the cards, because there was nothing that they could agree on in order to kind of get the sequence kind of rolling. Whereas, yeah, and so I think, so I think that maybe one of the key things about successfully facilitating virtual witnessing is that there has to be something that you agree on to begin with, or something that you trust that will allow you to work through the sequence, maybe.
Yeah, thank you very much. If I may just react super briefly. Another thought, but maybe I'm going too far, that I had while thinking about virtual witnessing and reenacting, which was inspired by your footnote on recipes. And I think Dana's work on recipes. Even when you reenact an experiment or a recipe, I mean, even there, you're trusting something of the text or person who's providing you indications. I mean, you're tacitly sharing some background knowledge or some skills, or in the case of scientific experiments, perhaps even some basic elements for interpreting the results. So maybe there is some trust and some common background, even when you actually perform and you reenact the experiment. But that's maybe too postmodern. I don't know.
Yeah, no, I think that's really interesting. I mean, I'm not sure if you can tell with this stuff, I am taking it into weird places, some of these ideas, and seeing what kind of philosophical tools can make of this case. So yeah, I'm up for all the weird things.
Okay, Ovidio, go ahead.
Yeah, really two follow-ups on Henny's question. So the first is this. So yeah, so you talk about this probative force, right, being obtained through this kind of active phenomenological way of enacting the experiments, right? But like for me, this suggests this kind of implies the fact that, you know, if we don't do that, then there is no probative force. I mean, you know, I cannot get the full kind of, you know, bam, aha moment in my head if I don't actually just materially replicate or enact the experiments, right? So this might be, I mean, for me, this sounds a bit weird, like the very fact that, you know, without having this enactment, I'm kind of doomed to not understanding fully what Newton is actually aiming to prove, right? So I mean, maybe you could say something about, I don't know, how you think this could also be like, you know, when a kind of a bypass or like another tool in the toolbox, kind of, you know, because I mean, yeah, there's this other way, there's this other bypass of like really understanding what I mean just by trying it yourself, and it's way better than the old school way, but that doesn't mean that the old school way is like doomed to fail, right? So I mean, I wonder if you see these as mutually exclusive or like kind of adding up, right? And the second point is kind of more your kind of the way in which you contrast yourself with Chapin and Schaffer's virtual witnessing thing? Because I take it that, I mean, sometimes it seems you seem to kind of want to replace their virtual witnessing reading of Newton, but sometimes you kind of feel, I kind of feel that you say that they're complementary in a way, right? I mean, you can have both, right? You can have both virtual witnessing reading of it as, you know, a rhetorical trope, let's say, but you can also have this enactment probative force, right? So I wonder if you could like make your relationship with Chapin and Schaffer a bit more precise on this.
I think I'm undecided, which is probably why I'm being a bit vague. Like I said, I have, in the kind of work I've done so far on this, I think I kind of have found reasons for thinking that material enactment gets you further on the road to, let's call it certainty or compelled assent or something like that. But I do have in the back of my mind this worry that it's just because I haven't been imaginative enough yet or creative enough yet to kind of think about how it is that virtual witnessing would work. I think that, and so like I said, I'm interested in kind of, I do have a colleague who I'm sort of starting to discuss some of this stuff with, and we might be able to come up with something interesting to say about virtual witnessing by kind of using some of the tools that we get from like the phenomenologists are using to understand kind of online interactions and things like that. But I'm not sure. So, you know, so I think part of it is just, you know, a failure of my imagination, but at this point, but I also think so. What you're saying at the start of your question about how there are how maybe material enactment is kind of just one tool out of many. I think that's probably right. I was thinking the other day I had to give a talk to our undergraduate philosophy students. Kind of their philosophy society does a thing they call Phil on Tap in a pub, and so you know you go and you give them a short presentation and it's a bit of fun, and then they, you know, they have fun and they ask questions, and then I guess they all get drunk after I leave. But and so there I ended up kind of thinking about the different kinds of certainty that philosophers seem to be able to identify. You know, so there's kind of epistemic certainty, this idea that you're kind of, you know, you believe this thing, you feel certain about this thing because of the reasons you have for that thing. We usually cash this out in, you know, propositionally in terms of premises and conclusions and things like that. There's also kind of psychological certainty where you kind of hold, whether you know, hold a belief very, very strongly, but usually for kind of external reasons that aren't really to do with the reasons that you would actually have for that proposition, but for some other kinds of reasons. The kind of example that comes up a lot in the literature about this is the kind of certainty that a mother has that her son couldn't be a murderer. You know, and it's the kind of, you know, it's the kind of certainty that, you know, it's the kind of belief that is very difficult to give up. Apparently, even in the face of a lot of evidence, a mother would never believe that of her son, that there could be a murder or something like this. And you know, so there's a few different kinds of certainty on the table that I think kind of that kind of describe different ways of arriving at a really, really strong belief. What there doesn't seem to be is a kind of certainty that kind of maps onto how Newton seems to think about certainty, especially when he's talking about how it is that, you know, a really good experiment can compel you to assent to a conclusion. You know, he does say in a lot of places like beyond possibility of doubting and things like that. So these are really strong claims. And so I was sort of toying with the idea of there being another kind of certainty that kind of, you know, that is a kind of certainty of grasping, that you kind of, you know, you have a kind of experience that gives you a grasp on the proposition, that gives you a really strong belief in the proposition, in a way that seems different to kind of what they call epistemic certainty or psychological certainty. And And I realized that, yeah, and so I think what I'm getting at with that is I think there are different, that there have got to be many different ways of kind of arriving at the kind of that aha moment, and it might just turn out that it's different for different people. I kind of demonstrated this to the students through talking about the Monty Hall problem. If you've ever come across the Monty Hall problem, you know, it's extremely divisive. A lot of people, you can show them many different kinds of proof that you should switch doors, but for a lot of people, they're kind of like, no, I can see the proof, I kind of understand the proof, but I just can't believe it. Like, and you know, for other people, they're like, no, I totally get that you should switch doors. I grasp that the proofs don't make any sense to me. And so I think that, yeah, and so I think that maybe this kind of this way of thinking about probative force, this kind of proof might just be, like you said, kind of one of many tools for the job. And it could be that you know, someone like Newton was anticipating different kinds of readers who would interact with the text in different ways. That some people would kind of virtually witness it, other people would you know, commission somebody to come and carry out the experiments for them and demonstrate for them. Someone else would actually do the experiments. Like, it could be that there's lots of different ways of getting there. Yeah. Sorry, that was a really long response.
No, thanks. Very interesting. Karen, please.
Yes, thanks, Kirsten. I thought it was very interesting, both your paper and the discussion so far. I'd like to go back maybe to one of Casper's suggestion, but also connecting it to something you said during the discussion on the notion of a proof. Yes, and you said, well, at the time, the meaning of proof was kind of vague, and it was a more lenient concept, as you put it. And I can see this, but I was wondering what you take to be Newton's contribution to, as it were, changing the meaning of the term proof, if at all. Yes, because I thought that, so in relation to Casper's comments on, as it were, the more polemical aspects, that that maybe Newton wanted to provide the term proof with a new meaning, and to dissociate it from the classical Euclidean model, and to, as it were, further the emancipation of a more experimental approach by claiming, look, you know, what we are doing in our experiments also amounts to a proper proof. Yeah, so it's not kind of an inferior type of reasoning, but it's an alternative, and the term proof can be used for this more experimental approach because it provides us with the same type of certainty or evidence that, according to the scholastics, could be reached by means of syllogisms or whatever. And so this would be, so I'm suggesting, well, my question is, do you think that Newton was in a way engaging in something like what they call today conceptual engineering? Yes, where we, as it were, deliberately provide an existing term with a new meaning for specific purposes.
Yeah, I like that term for it, conceptual engineering. I think that I think there's a lot of I think there's good reason to think that Newton was doing some conceptual engineering there. In a few places I've talked about Newton's rhetorical style, where Newton has this tendency, and I know that Stefan Deschamps has also talked about this in some of his work, that Newton kind of takes terms that are kind of already in use at the time, and kind of mean almost or something similar to what he wants them to mean, and then he ends up just kind of twisting the terms to his own needs, and then the words, because it was Newton, the words tend to kind of end up coming to mean what he wanted them to mean. Yeah. And you know, you see that in some cases he was really successful at doing that. So when Newton talks about mass, you know, it really catches on. When Newton uses the term hypothesis, I don't think it ever quite comes to mean what he wants it to mean. I think the word is maybe that there are too many reasons for people to hold on to other usages of the term. I think principle is another term that Newton kind of comes and takes to mean something slightly different to what other people mean, and so on. Newton's definitions, the way the way he uses the word definition ends up being quite different to the way that other people do, and so on. So he does this all over the place. And so yeah, I think I haven't really thought about this in relation to the concept of proof, but I think it's very plausible that yeah, for various reasons, Newton is kind of bringing in the term proof to try and make it mean something different to what it meant before, or to try and apply it in a case that it hadn't been applied to before, and maybe to distance it from the kind of Aristotelian way of doing business. I mean, it's clear that because there is this whole history, this in Newton's work, that he had tried to complain. He had claimed that that experiment 6 was an experimentum crucius, a crucial experiment, and that it yielded certainty, and that and he had made these really strong epistemic claims about the power of a really good experiment. And it hadn't gone well for him at the time. People just didn't get it, and so then you suddenly see in the Opticks him sort of trying the same thing again, but in a slightly different way. He gives a few more experiments. He kind of recognizes that maybe one experiment isn't quite enough. Let's give a whole sequence, and but then he calls it a proof. Like he doesn't claim certainty, but he uses other kind of really strong epistemic language to kind of claim, to make claims about what's going on. And like you said, it doesn't quite look like what other people have been doing with that word. Yeah.
Okay, thank you very much. So just a short remark. I think that Kant does something very similar in the Critique of Pure Reason. Yes, he also used the term proof, but again in a very different way, different from the classical notion, but also different, I guess, from Newton's one. So this ambition to adjust the meaning of terms, or to provide them with a new meaning in accordance with their own purposes, I think, was more widespread. Yes, at least it's also very, very clear from Kant. And there are also some passages in Kant's work where he explicitly mentions this. Yes, the need to provide existing terms with a somewhat different meaning given the new context in which they're being used. Yes. So I think that's very nice. I have another question, but I'll wait until maybe some others have contributed as well. Thank you.
Thanks.
Yeah, sure. Alan, go ahead.
Thank you. Am I audible to everyone?
Yep. Yeah, I can
Great.
hear you.
Just very briefly to Karen's point, just now, I'm still an undergraduate, so I'm still reading Thomas Kuhn. And I was struck that one of the features that he presents of the paradigm shift is that conceptual engineering, that change of terms for one's own purposes. But I actually was wondering if whether the bucket experiment might be a good case study of the virtues of this virtual witnessing or actual experimentation, because Ernst Mach really tries to pin Newton on this and saying that, well, your experiment can't really be done in the way you want it to be done, because you can't really ignore, Newton writes that the stuff in the universe have any bearing on the concaveness of the water, and Mach is sort of saying that, well, in that case that experiment can be done because you're talking about a bucket and a void, and so he really presents that as being a thought experiment more than anything. But I'm wondering whether he is showing a sort of real limitation of reenactment, or whether he just simply didn't agree to the first principles that Newton is putting in his definitions, and whether he just simply did not want to follow through that sort of proof by experimentation. So I wonder whether proof by experimentation does sort of translate well into the Principia and into the bucket experiment, which is sort of a proof within a proof. Yeah, I have other thoughts, but I'll wait to see what people think, I guess.
Yeah, that's a really good question. I mean, so one thing to remember is that virtual witnessing, the way it's been introduced and discussed in the literature by people like Chapin and Schaffer, is that it's like kind of a writing rhetorical technique that's used in papers, in books and papers in the 17th and 18th centuries, to play this certain kind of role where you make a person feel as though they have witnessed the experiment, and so on. So it's supposed to be it's a literary technique, and so in that sense, I don't think the bucket experiment would count as a case where the goal is to kind of facilitate virtual witnessing. It does, however, raise a really interesting thought, though, which is that maybe, like philosophy has a long tradition of using thought experiments and also intuition pumps and various kinds to kind of give people, to kind of test concepts, and a really good thought experiment is something that's supposed to kind of have the capacity to surprise, to yield new phenomena and all that kind of stuff, all the stuff that we expect experiments, like material experiments, to do as well. So it does seem plausible to me that you could virtually witness a thought experiment. This now the thing that I'm kind of thinking about, and I'm not sure what the answer is there a difference between virtually witnessing a thought experiment and actually enacting a thought experiment? I have not thought about this enough myself to know if there's a clear answer to this. I wonder if anyone else in the room here kind of has any thoughts on this, because that's a really interesting question about thought experiments.
If there's no direct
I like it how
the
undergraduate in the room managed to floor all of us. I'm going to have to go and think about this one. This is really interesting. Yeah, I'll have to send you an email if I have any interesting thoughts about this.
All right. Thank you, Alan. We'll go to Rafael next.
Thanks for the paper and the discussion. I had a question somewhat similar to Henny's and Marco's on virtual witnessing and enacting, but perhaps I'll frame it differently. Let's say someone enacts the sequence of experiments while disagreeing with one of the definitions that are supposed to guide them. What happens then? Do they become convinced by the result of the experiment so that they now agree with the definition? Or is it that they have enacted the experiment while still disagreeing, and which seems to mean that they haven't experienced properly the sequence of experiments? What would you say in that example?
Oh, that's a good question. I think it probably depends on the person and how much they disagree, how open they are to, to the experimental sequence and things like that. Like, I think this might be one of those things where it could turn out to be a real block to you accepting the sequence and therefore properly enacting the sequence and having the right kind of experience. Like I kind of said in my introductory talk, my sense is that maybe Hooke and Newton, well, maybe Hooke is a person who is kind of in this situation when it comes to Newton's optical work, and he just doesn't think that the experimentum crucius reveals the phenomena that Newton thinks it does, and they just don't seem to be able to see eye to eye on this ever. But it could turn out, I mean, those are like, especially the last two. So most of Newton's definitions are not, as I say in my paper, that they're not kind of controversial, but those last two definitions, they're especially the one about color, is quite a controversial definition, but it's also not something that you can just stipulate. Like Newton stipulates that at the beginning, but that's only because he's carried out these experiments and he knows that definition kind of, you know, works as a framing device for his account. So it seems plausible to me that somebody else could go in being skeptical about that definition, but then through the process of carrying out the experiments and kind of enacting them might come to then kind of go, oh, actually, that definition does work here. Okay, I'm going to accept that definition. It might be that then they have to kind of redo the sequence to kind of go, okay, now that I kind of understand how that works, now I'll do it again or something. But yeah, so I think that the prescriptive framework does do an awful lot of work. How easy is it for someone to give up their prescriptive framework or to switch frameworks? I'm not sure. It probably depends on how much skin you have in the game. But I'm not sure. Yeah. Is that what you're getting at with that?
Yeah, thanks.
Okay, Ovidio, did you have another question?
Yeah, but I changed my mind for now. I'm trying to kind of frame it a bit better. So if anyone else wants to go ahead, please do.
Karen, go ahead.
Yes, yeah, so I have a follow-up question to my earlier question, but it's a bit difficult for me to articulate it because I would like to say something about a kind of a second order level of Newton's account, because we've been discussing how actual experiments can convince the reader, and whether this requires material enactment or virtual enactment and so on. But I was wondering if there is also a kind of second order attempt to demonstrate something, namely to demonstrate that that this kind of experimental proof counts as a proof in the first place, and that so we, as a reader, you're not just getting convinced of what he has to say about refraction and so on, but you're also convinced that this kind of, you know, this systematic way of carrying out experiments gives us real evidence about light. And yeah, since I'm interested in metaphilosophy, I was wondering what you think about this. Yes, that and I do not know if Newton was aware of this, but also given Casper's earlier comments, I think that he might have wanted to illustrate or to demonstrate by way of illustration that his type of doing natural philosophy is really valid and does provide us with real evidence. Yeah, so that also at this higher level, the reader comes away from reading the text with a different view of what a proof is, what evidence is, and so on.
I think that's really plausible. That's one of the things that's going on here. Yeah, I haven't thought about this very much, but yeah, this idea that that by kind of experiencing the probative force of the sequence of experiments, you walk away going, experiments can have probative force. I think is really plausible, because again, in Newton's kind of earlier writings, when he's having his debate with the Jesuits, especially in his correspondence with Lucas, it's clear that Newton is really trying to kind of articulate why it is that kind of the experiment should compel you to assent to the proposition and things like that. And he really struggles to convince people of this. And so, yeah, I think it's really plausible that this is kind of a possibility proof for proof, at the same time as that it's a kind of a proof for the proposition, for the theory of light.
Yeah, and so if I can add one thing, because what I liked in Casper's comments, what he was Casper, what you said, that that as it were clarifying the strength of the experiments is much easier in optics than in astronomy, and which was his main concern. Yes, I don't know, but it seems to me that Newton wasn't particularly interested in light, but that it allowed him to think about the force of experiments and how they ought to be conducted, and in relation to the earlier criticisms that he received, but also in relation to his more fundamental interest in the planets. Yeah, Casper, am I rendering your one of your points correctly?
Yes, I think so. The way I kind of see it is that that Newton with the optics much more convincingly than with the Principia was able to successfully show how certainty can be achieved in physics, different than mathematics. And I think I thought about this. I don't remember one of the first questions that proof back then meant different things. Like it could mean something Euclidean proof or syllogisms or what Newton did here, but that's still the case now. I think there's a big difference to what a logician does, and what a physicist does. They prove things differently, and the way I kind of saw it was that Newton with the optics found like a nice way out of the swamp of uncertainty and speculation and what does it mean, and I like the Karen's point that it's like a proof of concept of proof. Like the optics also does not only tell us something about light, it also tells us something about proof, and that might be one of Newton's points. But I'll have to ask my supervisor before I can make that statement.
Yeah, no, that's that's a very interesting idea. There is another paper, again, kind of spiraling off from this original idea. So one of the things that came up when we wrote the paper on the aesthetics and agency in experiments paper was the idea that that a lot of the things that we're talking about, this kind of the probative force of an experiment, seems to, our account of it seems to only work for kind of experiments that are really kind of direct and immediate. So things where you are sort of directly interacting with and intervening on your target, manipulating the instruments yourself and kind of being able to insert yourself into the experiment as an individual. It seems to, so far the things that I've talked about and collaborated on seem to only work in that kind of context. And of course, like we were getting at here, it's kind of a pretty weird situation, actually, especially in modern science, where actually you have, most of the time when you're doing experiments, you're actually at a distance from your target in a lot of ways. Either you're, and even Newton encounters this being kind of distant from, you've got distance from the celestial objects that you're studying. You've got distance from the micro objects that you're trying to look at. You might have kind of there's different kind of distance that comes from everybody in your lab having a different role in the carrying out the experiment. So no one person is kind of experiencing the entire experiment. That you've also got the kind of distance that you get from, I don't know, the stuff that goes on inside a hadron collider or whatever, and so there is this idea that actually, that this kind of account of experiment works really nicely with these kinds, but are we able to say anything interesting about those other cases? Is it the case that, say, modeling the planets or modeling motions of bodies can do some of the same work for Newton in the Principia that carrying out the experiments physically can do in the optics. Because certainly the way that Newton articulates, say, the third law, the three laws of motion, especially the third law of motion, it's controversial. The way that he kind of applies it to this case of attraction when it's, which is kind of unusual, and it sort of means that a reader would have to kind of, work through the sequence, maybe to kind of understand, to work through the modeling process, maybe, in order to kind of come to think that actually, yeah, that was an acceptable way of characterizing that force or something. It might turn out that, yes, so it might turn out that there's something interesting there that in terms of kind of how you have to process things, and it might turn out there's some parallels that we can talk about in relation to how Newton convinces you in the Principia as the optics, but it's very half-baked at this point.
Yeah, I think it's also what I thought about now. I'm not sure what conclusion comes out of this, but just the difference between the Principia and the optics is also that when you're doing astronomy, you're always reliant on other people's observation. There is no one lifetime. You cannot do enough observations to create a theory like Kepler or Newton, while with optics, you can theoretically do it all yourself in 1 or 2 very productive days. You can just all do it yourself, but in astronomy, you need all the you're always working with testimonies in some way, and that might be a difference as well, but just something I thought of. Ovidio, I think that might be the last remark, so please go ahead.
Yeah, so again, if anyone else wants to jump in, I'm happy to drop it. I was basically gonna like ask something very similar to what you just said, because one way to say it would be, well, it's not about a different type of proof. It's like a different type of discipline. I mean, just astronomy just works like this. These are the types of observations and the types of experiments which you can make, and basically what you observe is a certain position of the planets on the sky, and what you just want to get out of is it like here or there, like in relation to a certain point or a certain celestial object. But then I thought, no, that's not true, because look, so there are, so for instance, Galileo, right? When he wrote the Starry Messenger, right? I mean, now that I'm thinking about it, I think that's basically the most, I mean, for me, that sounds like the most paradigmatic case of like virtual witnessing, right? Because he was writing this observation book, right? And saying, look, this is how the moon looks through a telescope, and this is how the stars look, and blah, blah, blah. And the point wasn't really to make you enact the experiments, because it was very hard to come by a telescope and so on, right? The point was to kind of take your hand and, walk through it and kind of convince you by, shooting every type of rhetorical strategy at you, right? Including this one. Look, I'm gonna draw the thing for you to see it, right? So I mean, yeah. So I think in a way, I'm more convinced a bit that Newton's proof is way more hands-on than than Galileo's, let's say. But what I actually wanted to say, and this is going to be the last thing, was like connecting to Alan's point. So is now the standard reading the fact that the bucket experiment was a thought experiment? I mean, is that the kind of the received view, as it were?
Yeah, the bucket. I think it's established that the bucket experiment is a thought experiment. Yeah.
Right. Okay. Because yeah, I'm thinking,
I mean, it's the classic example that comes up whenever anyone thinks about thought experiments. Everyone goes, "Well, the bucket experiment, is it like that one?" Yeah.
Mm-hmm. Yeah, because I was wondering if you couldn't read the bucket experiment, or if you couldn't kind of use it to make a distinction between the actual hands-on enactment and some other type of more thoughty experiment or virtual witnessing or whatever, right? Because the bucket experiment, I mean, presumably it's easy to replicate, right? I guess.
I mean,
But no,
you can
so
definitely, I imagine that in order to kind of, in order to be able to kind of properly experience the bucket experiment, you need to, you know, you need to have kind of some knowledge or experience of how water works, you know, and how spinning, you know, like it kind of relies on you having some experience with, I don't know, playing around with a bucket or a cup of water or something at some point, and kind of having that, because you kind of need to have that knowledge that the water kind of dips in and things like that, that I think that a lot of people have just from kind of experiencing life and stuff. I don't know. I remember my dad explaining it to me when I'd been on a scary ride at some point and like showing me a dish of soap swinging around in a I don't, you know, like that, you know, there are things that you just kind of learn as a kid that kind of equip you to be able to understand these kinds of experiments. And so, you know, and but the idea is supposed to be that you can't carry out this experiment in real life because there's no such thing as a, I don't know, as a disembodied bucket in an infinite space or whatever, right? So yeah, that's what makes it a thought experiment.
No,
But
yeah,
but I guess coming back to this might come back to that kind of that point about whether you have to accept the definitions or the framework to begin with, because presumably if you don't kind of think that that's how water moves or that's how buckets move, then the thought experiment just isn't going to work for you.
Right. I think that was our last question we have time for. I want to thank Kirsten again. It was a very interesting paper, very interesting discussion afterwards. And I hope to see you all very soon. And thank you again. And
thanks so much for inviting me and for all of your questions. I've filled up a huge document of notes from this discussion that will help me with moving this stuff forward. So I really appreciate all of your work on this. Thanks very much.
Thank you very much.
Thank you.
Bye.
See you later.